contact information on the website. So if you have further need to communicate with the presenter or have another question, you can contact them directly. And with that, I'm going to turn it over to our next presenter. Thank you.
All right, can you hear me okay? I hope.
Perfectly.
Okay, so hi, I'm Greg Knothe, and for the past 5 years, I've been working on the Peace River as a biologist and with FWC in their Ecosystem Assessment and Restoration section. And as of just 2 weeks ago, I've actually moved over to the Polk County as their Water Resource Coordinator. And today I'll talk about some of the work I was a part of, where we conducted a Peace River watershed threats assessment. We prioritized restoration from the sites we identified, and then where we're going from there. Next slide, please. So why do a threats assessment? In order to restore the natural function of a river system, we must first identify those areas of habitat degradation. And for our project, the threats assessment identifies, inventories, scores, and then prioritizes restoration of these impaired sites. Impairment was based off locating areas of bank erosion, bank mass wasting, which basically means bank failure, riparian zone degradation, channel alteration, areas of point and non-point source pollution, loss of floodplain connectivity, and fish passage issues. Next slide, please. And then just carrying on a little bit about the background of it. So we covered the navigable reaches only. So basically focusing on the main stem river and some of the larger tributaries. And it's important to differentiate between localized and large-scale restoration issues. We're identifying localized areas of degradation. And of course, large-scale issues might be more suited to, GIS analysis or watershed analysis. And really, that's where this project started. It got started based on a large GIS study that FWC and their GIS department conducted, basically ranking all the watersheds within Florida based on their degree of threats. And then it ranked the watersheds basically on a need for preservation or enhancement. And of course, with the Peace watershed having a long history of degradation, it was ranked very high for enhancement. Next slide, please. Okay, so some of our methodologies. We were following a rapid assessment methodology developed by Chris Metcalf with U.S. Fish and Wildlife Service. And these are the 3 manuals we were following that he put together. And the top 2 were the main ones, the habitat evaluation form, and then the Fancook channel stability rating. The bottom one, I won't really talk about in this presentation. We also identified unpaved road crossings and then estimated the total sediment risk index of those 2. Next slide, please. And a lot of Chris's work is all based off Dave Roskin's work. He's one of the leading restoration and stream assessment scientists in the country. And these are 3 of his books here on the bottom. The Watershed Assessment of River Stability and Sediment Supply. And then he has his River Stability Field Guide. And then the 3rd book is his classification systems of rivers, basically dividing out based on numerous things like valley, slope, sediment type, etc. And then he also offers 4 levels of training under him. And that's something that Chris, who I mentioned on the last slide, actually helps Dave teach. So they work together a lot. Next slide, please. All right, so I mentioned the scoring system. This is it here. So it's called the Severity Score. And this table, you can see on the top, has the risk factor and then the different scores for each one. So the first one is the Fancook channel stability rating, and this is an index, which I'll talk a little bit more on the next slide. And then moving down, you have channel alteration, bank erosion, and then bank erosion hazard index. That's also another indice built into the scoring system, which I'll talk about in a few slides. And then local non-point source pollution, point source pollution, shoring structures, water odors, fish passage barriers, and then the bottom 2 are broken up riparian buffer, and floodplain access by left and right bank according to the scoring system. So it has a minimum of 0 points up to 16.5. And then we divided that also into 3 groupings of low, moderate, and high severity, which I'll talk about later. Next slide, please. So there's a lot of material on here. This is the Fancook channel stability rating, originally put together by Fancook in 1975. However, Rosin altered this for coastal sandbed streams, more fitting to the Peace River, of course. Basically, it divides the river into 3 segments: the bottom, lower banks, and upper banks. And I don't think I have enough time to go into this into too much detail, but basically looks at things like scouring and deposition, large woody materials, presence of sand dunes, sand particle size, whether you have an invasion of silting clay particles due to erosion, deposition, bank erosion, obstructions of flow, rooting density, channel capacity, which basically is looking at whether the river has connection to the floodplain or whether it's been over-widened by stream bank erosion. And then also looking at potential of debris jams, mass erosion events, etc. And then you get your whole score, and then it's based on, as I mentioned earlier, Rosin has the different stream types. So the Peace River falls into a C5 stream type based on its slope, degree of sinuosity, sediment type, etc. So I think that's all I can really talk about that. I'll just give you a quick overview. So next slide, please. And then this is the second indice that's built into our scoring system, the Bank Erosion Hazard Index. Basically evaluates the susceptibility of a stream bank to erosional processes. And 5 main variables going into that, which are, the first one is bank height to study, or bank full height ratio, which basically determines whether that particular study bank has access to the floodplain. The second one is rooting density. Third is rooting depth, then rooting density, bank angle, surface protection. And then there's 2 adjustments based on bank material. Of course, different sediment types are going to erode more quickly. Clay is going to hold together better than sand. So you have some bank material adjustments. And then you have stratification adjustments. If you have different layers within the bank of, rock over sand or something that's going to alter the erosion rates, you also account for that. All right, next slide, please. And this slide gives you an idea of a site we identified. So this is on the main stem Peace River up by Zolfo Springs. And you can see it ranked out at 6.5 severity, which is a moderate severity according to that severity scale. And this stretch of river, I guess that's one other thing I didn't mention. So for the Fancook, that's for a reach of river. It's not just one particular site. It can be up to several miles if you're seeing the same conditions. So we apply that Fancook channel stability rating oftentimes to numerous sites. And then moving down, channel alteration, and this site was bank mass wasting, so it got 1.5 points, and riparian buffers weren't in the greatest condition. So so that ranked out as moderate severity. We have the reach length and some other ancillary data. All right, so let's go to the next slide and talk about the results a little bit. So you can see from this figure, this is a Peace watershed, just with the main tributaries listed. And the areas in green are the places we covered. So we covered the entire main stem river from Saddle Creek, Peace Creek confluence up by Bartow all the way down to Port Charlotte. And then we got into the tributaries a little bit. Of course, we were just mostly focused on the navigable areas. We ended up hiking some of the smaller creeks like Charlie and Horse as we moved up. And next slide, please. So this has all the results. So as I said, we started up towards the confluence on the main stem, and we really didn't identify many sites on the upper Peace watershed. But as we moved down below Polk County, down into Hardy and DeSoto County, you can see a lot of sites popping up. The low are shown as a little green diamond, yellow as moderate, and red as high. So you can see they're really dense in that central region, as well as on Charlie Creek and Horse Creek, what we covered at least. So overall, we surveyed 168 river miles and identified 512 sites. The Peace River, we covered 104 miles approximately and identified 278 sites. I won't go into each of these individually, but Charlie Creek identified assessed 22 river miles and identified 117 sites. So you can see based on that, the sites, if I could have included a site per mile, but it would definitely be higher for Charlie Creek than the Peace River, at least for what we covered. Horse Creek, we surveyed about 15 river miles and identified 63 sites. And I think that covers that slide. And this slide here has a lot of the similar information. However, it breaks down the frequency of occurrence of the different severity scores. So if you just focus on the red highlighted area, you have the water body, severity score, range, frequency, site length. So as I said, we identified 512 sites, and this also has the site length. So it's about 114,000 linear feet. Of course, it'd be a lot more if you computed that into acres. And then the frequency. So majority of the sites ranked out for the Peace River watershed as moderate severity, followed by low and then high. And that was a theme that was carried out on most of the tributaries as well. Next slide, please. So now I'll discuss some of the main causes of impairment in the Peace. And really it all came down to agricultural impacts for the most part in that centralized location of the watershed. And a lot of these areas have been converted to pastures, which has either been actively or passively. And we also observed a lot of instability related to areas that have been cleared for farm roads way too close to the stream. And then you can see on the lower picture there, you know, the cattle have cleared a lot of these or kept the areas pretty clear of vegetation, really prevents anything from taking hold in those areas if there's heavy cattle usage. And then also from the water quality standpoint, of course, there's a lot of sediment coming off these banks, as well as non-point source pollution from cattle waste. Next slide, please. So we also commonly observed recreational impacts. This would include access points for fishing, homemade boat launches, and of course, fossil hunting's pretty huge on the Peace River. So people are digging in banks, also digging channel bed, which is disrupting the natural sediment regime of the river. And then these next 2 points are more anecdotal, but interesting to point out either way. The impact of hurricanes on the Peace River stability, it's definitely impacted in some ways. So in particular, Hurricane Charlie made landfall as a Cat 4 and pretty much went straight up the Peace River and uprooted countless trees in the riparian corridor. And then this impact, as well as with heavy cattle usage, may have inhibited recolonization of a lot of the riparian vegetation, as well as causing debris jams, which can lead to more erosion rates or higher erosion rates. And another kind of anecdotal change would be the impacts of changes in stream flow on the Peace River. So whether it's anthropogenic or climatic, the Peace River has experienced some changes in annual mean flows. And what this really translates into in a river system is basically the long-term annual flows of a river really govern the shape and size of the active channel. So when these flows are reduced, the river will often adjust. And oftentimes it'll abandon historic floodplains and create terraces. And then with that, it creates new floodplains at a lower elevation, which during this evolution process really results in more stream bank erosion and instability until it can reach some sort of equilibrium. Next slide, please. So this figure just shows some photos throughout the study. I'll just point out a few of them. The top left was up on Shell Creek. You can see this stream is really cut down over time and lost floodplain connectivity in many sections. The next few are more stream bank erosion. Of course, you have, cattle and cattle waste related to that on the kind of central left side there. The middle right is an example of some recreational erosion where people are just, going down to the stream or fishing or launching kayaks. The bottom left is an example of a road crossing. So we see these pretty common, more so on the smaller tributaries like Horse and Charlie creeks, where people either drive tractors or trucks across the road, across the stream, and make a ford. And so you can see, the bank there was about 6-7 feet high, and all that sediment, of course, ended up in the river. And you can I've looked at this particular site from Google Earth, and you can see, a huge sediment plume downstream from that. Another thing we identified were just impacted tributaries. So that's the next slide, or the next photo to the right of that one. It's kind of hard to point out on here. All right, we can go to the next slide, thanks. Okay, so we'll discuss a little bit some of the impacts of accelerated stream bank erosion, since this seems to be the overlying theme on the piece and some of the tributaries. So with that, you often lose sensitive macroinvertebrates and fish species. It can impact spawning and rearing habitats of fish and invertebrates. Also, habitat complexity can be altered, and you can lose a lot of those nice microhabitats if you have a really high sediment load in the river. And this can impact your pool habitats that can get smothered out, and all those unique habitats like little protrusion pools from logs and those outside lateral scour pools. And a lot of these can be filled in, which really hurts fish habitat. In-stream cover, of course, it makes it really difficult for some more submerged aquatic vegetation to survive in a system like this if you have that high of a sediment load. Also moving down, water quality. So with stream bank erosion, you often have increased or over-widened streams or increased width depth ratios. And with that, as the stream over-widens, you have shallow stream bed features, which with that, you lose that nice canopy cover that a stream typically has. And that can also lead to increases in water temperatures. Next slide, please. So as I mentioned earlier, these are more geomorphological impacts. So I mentioned stream over-widening due to stream bank erosion and reduced width depth ratios. Of course, that hurts fish habitat, as numerous other impacts. So with that, you also have a negative feedback loop. So stream bank erosion causes aggradation, which is basically an increased level of your base of your stream bed, which then with a decreased slope basically leads to more stream bank erosion because the water has to go somewhere and it pushes harder up against banks. And some studies have shown that stream bank erosion can, in a really unstable river, can account for 80% of the sediment supply. Okay, next slide, please. So as part of our study, we were tasked with prioritizing our data for restoration. And we found GIS heat maps to do this best. And basically heat maps are visual representations of data where data values are displayed in a matrix of colors. And additionally, the heat maps can be weighted based on study objectives. So for our study, of course, we had our severity score, which I've mentioned several times here and what goes into that. We have site length, and then we have our density of sites. So all of this goes into putting together this heat map. And you can see this is basically on the bottom right has a piece watershed, and then you have an inlay from that. And basically the way the heat map broke it up was 6 focal areas within the piece, the main stem Peace River, mostly on that northern area where we saw earlier all the sites. 2 on Charlie Creek, one that's really dense, high density of sites. as well as one on Horse Creek and one down on Prairie Creek. So the idea behind this really is, if we're going to implement large-scale restoration, large-scale stream restoration, this would provide the most bang for our buck. We can reduce costs on design, material, mobilization if we do large projects instead of piecemealing it together one project at a time. And one other thing worth mentioning is, we only covered the navigable reaches throughout this study. We did some additional riparian analyses, which I won't go into detail, but basically, we found a lot of issues on the tributaries, of course. So, all right, moving on to the next slide. So I included this slide kind of just as a break or a pause, and when working on the project, I thought it was a bit overwhelming at times, just seeing how many sites and we were identifying and the degree of impacts on the Peace River and some of the tributaries. And it's just, a bit overwhelming thinking about how much work needs to be done. And another issue is most of this area is all privately owned. So it definitely makes restoration more difficult. So it'll be quite an undertaking to implement large-scale restoration, and will require partnerships with numerous agencies, finding a lot of funding. Stream restoration isn't cheap. And then, of course, getting landowners on board, which I've done a little bit of. So we can go to the next slide here. So where do we go from here? We partnered with U.S. Fish and Wildlife Service to restore and monitor 2 high-ranking impairment sites. And also, as part of this grant, we are conducting Myakka River threats assessment and fish assemblage monitoring. And this was funded from FWC's Aquatic Habitat Restoration and Enhancement subsection and Florida State Wildlife Legacy, which also funded this initial project. And as I mentioned, we found a few landowners that were willing to work with us and excited about conservation and stabilizing their stream banks. And, they're losing a lot of their land to the river every year. So we basically we have 2 sites that we're restoring. One site near Sulfo Springs, which is about 550 feet long. And also another thing worth mentioning is we calculated the erosion rates of this site using the bank assessment for non-point source consequences of sediment model, or BANKS model. And the erosion rate for this site is about 120 tons per year. And the second site, the 1,000-foot restoration site near Arcadia, had an annual erosion rate of about 200 tons per year. So the 200 tons per year is equal to about 20 dump trucks every year going and dumping their load in the river right there. So kind of alarming. Next slide, please. So lastly, I'll tell you a little bit about how we would restore if we were going to do large-scale restoration, and then how we're going to restore our particular sites. So as I mentioned earlier, David Roskin, he basically has pioneered this method of restoration known as natural channel design. And basically it's a method of restoring a stream by engineering changes that emulate natural conditions and maximize function. So basically this is done by doing a reference reach survey. So we would go to a river system that is stable, and stable meaning it's not aggrading or degrading over time, and then apply that that survey to a larger scale or a different river system based on the current flows. And this is opposed to traditional methods, including riprap or concrete or gabion or geosynthetics, where you can see on the top right is a stream or more, and I guess line concrete canal that has obviously been impacted, and then they tried to kind of hold it in place with a bunch of concrete. It has no connection to the floodplain. On the bottom, you have a stream that's been restored through natural channel design. So you can see it lost connection to its floodplain. They basically, on the center picture, this is right after restoration, has connection to the floodplain again, and then goes up to that terrace level. And then a few years after, you can hardly see the stream because it's so covered with vegetation. So moving to the next slide. However, our sites are more on the outside meander bends, that high near bank shear stress environment. So it has a lot of stress being on the outside bend close to the deepest part of the river. And we're stabilizing mostly using toe wood in the most high stress location of it. And basically what goes into that is you can see the cross section here on top. And basically we gather the wood material and lay down foundation logs followed by root wild logs, and then use coir wrap sod and follow a native vegetation plan. And just 2 more slides here. So I think I'm getting towards the end of my time. So monitoring, we're going to do pre and post surveys at each restoration sites and 2 controls looking at fish communities, permanent cross sections, bank profiles for erosion rates, photo points, and then also side scan sonar. So there's a few images of us doing that out there. So in summary, we found an alarming number of sites in the Peace River and tributaries, and it's going to take a lot of work to restore these, but it took a long time to really mess them up. So we're starting with a pilot project, 2 pilot projects, and monitoring those with hopes that this will get the ball rolling and we can implement large-scale stream restoration in the future and monitor success. And thanks. I'll take any questions.
Thanks, Greg. We have about 4 minutes for Q&A right now. If for those of you joining late, please go to menti.com and use the code 639808 at the top of your screen. And Greg, feel free to start answering these questions.
Okay. Let's see. They're kind of moving around at me. So what techniques of restoration would you recommend for Charlie tributaries of Peace River? I think I went into that already with the natural channel design methods. I think that would be best. And there's a lot of consultants now, even in Florida, that are aware of this methodology. It used to be more so in the Northeast and out West to find people that know how to do this, but now it's really catching on. Does FWC conduct this kind of habitat assessment statewide, and are those results available? So I didn't mention that, but the original threats assessment was done on the Yellow River, which goes into Alabama all the way into Florida. So that was the first one conducted by the Nature Conservancy. And then these were the 2 next ones. I didn't mention either. We did one of these on the Withlacoochee watershed, and then we did the Peace, of course, and now we're doing the Myakka. And they've just kind of been individual grants. It hasn't been like, implementation of this statewide yet. Did you investigate headwaters of the Peace River given increased urbanization? No, we didn't really look into that. I did mention we did the riparian study, that basically used the results of the areas we did survey, and then we applied that using basically a regression analysis to streams that we didn't have a chance to cover and estimated the degree of impairment. So that was something we included in our final report, which we can make available to anyone that wants. And could Amendment 1, 2014 funds be used for stream restoration? I do not know enough about that one to answer that. Do you think gradual erosion, like in a drainage ditch, needs a different restoration strategy? I mean, you could definitely use this same restoration strategy. It's just, how much you want to invest in the project. One thing I didn't mention about the natural channel design versus some of the riprap and historical is typically it's a lot cheaper too and more resilient. And I think that's about it for time here. Thanks.
Thank you so much. We really appreciate that. And to everyone out there, again, don't hesitate to enter your questions through Menti. We are not going to be using the hand raising feature or the chat box for questions today. We're doing it all through menti.com. That way they can be captured and permanently recorded.